Hello, class. Today, we're going to start by looking at this famous image taken by the Hubble Space Telescope. The way they took this image was they found a very, very dark part of the sky, and they pointed the Hubble telescope at it for 2 weeks so it could absorb all of the faint light coming from that area. And it took this image. And so, what this image is of is galaxies, mostly. And there's roughly somewhere around 1,500 galaxies in this image. And the reason why they took the image is they wanted to figure out how many galaxies were in our universe. And so, in order to figure that out, what we need to know is how big was this area of the sky. If it has 1,500 galaxies in it, then we can multiply it by the entire sky and figure out roughly how many galaxies are in the universe. So, the size of the sky in this image was basically the same size as Roosevelt's eye on the head of a diamond. Excuse me, a dime, not a diamond. And that's how big it was. And that allowed them to estimate that there's somewhere between 50 and 100 billion galaxies in our solar system. Before we go any further, we're going to need to figure out what exactly a galaxy is. You're going to be taking notes on this galaxy note sheet and filling in your information there. So make sure that you're following along, and if you need to pause it, if I go too fast or you miss something, you can back up. So we start with what a galaxy is. It's a large group of stars and gas and dust collected together. And of course, anything that goes along with stars, like planets and solar systems, etc. Our galaxy is the Milky Way. The closest one to us is the Andromeda Galaxy. They're roughly the same size. Stars can have anywhere from millions to trillions of stars in them. And they rotate around a central area within the galaxy itself. And most of the galaxies, astronomers think, contain a supermassive black hole at the center of the galaxy. And that's one that has a million or billions of times the mass of our sun. So a really big black hole, kind of crazy. So what are the parts of our galaxy? Like a spiral galaxy, well, it has a disk, which is this flattened area, okay, with collections of stars and gas and dust. It swirls around the center of the galaxy, the spheroid at the center, okay? And this is, again, where our supermassive black hole is, where heavy concentrations of gas and stars are, and then the arms spinning around the outside. So let's get some specifics about these galaxies. So a spiral galaxy, this is a type of galaxy that is middle-aged, and it has rapid rotation. It does have star forming in the disk, and the reason why we have star forming in the disk is because we have gas being concentrated as the arms swing around. It does have gas. Because it does have gases, it can form stars. Some examples of spiral galaxies, of course, are the Milky Way, the Andromeda, which I've already talked about, and two others are the Pinwheel and the Whirlpool. So you should have all that information filled out on the spiral galaxy section of your note sheet. Moving on, we have elliptical galaxies. You can see these are definitely different. There are no arms on these. These are older galaxies, redder in color, and they don't really have any gas, so you can't form any new stars, and they don't have arms. So some examples, the Sagittarius Dwarf Spheroid and Virgo A. These are examples of elliptical galaxies. The other type of galaxy we're going to take a look at, the last type doesn't fit in spiral galaxies, no arms, doesn't fit in elliptical, no round shape. It is no specific shape. And we have all kinds of star formation going on here, typically younger stars. A couple of examples, the Antennae galaxies and the Mice galaxies. These are examples of irregular galaxies. You're going to do an assignment today on galaxies. You're going to need to use the textbook. Those pages are scanned into the Google Classroom.